So now we're going to do a problem that involves trig substitution and a couple of other methods all in one problem. This is taking the antiderivative of 6x times the square root of 4 minus 9x to the fourth. Now, again, u substitution wouldn't work here because the derivative of what's inside is negative 36x cubed, which would leave me with some extra x stuff in the bottom if I did u substitution. So I'm going to jump right into the trig substitution. But there's one adjustment I need to make. You see how the patterns here are squares here, and I have this thing to the fourth? What I'm going to do is I'm going to rewrite that 9x to the fourth as what it is squared. So what that means is this is 4 minus, what do I need to square to get 9x to the fourth? Well, that's 3x squared. Squared, like that. So now, if I look at this, I can see, okay, so I've got a function inside of a function right here in the middle, which is 3x squared. And when I take the derivative of that, it's 6x, which would cancel with what's out here. So I'm going to start by doing a u substitution. So I'm going to let u equal 3x squared. I'm going to find what du is. That would be 6x dx. And I'm going to solve for dx, so it would be du over 6x. And then I'm going to replace all that stuff in there. And that would be the 6x down here and the 6x from the du. That'd be 6x times the square root of 4 minus u squared now times du over 6x. And those 6x's cancel out quite nicely. So what I'm left with is the antiderivative of 4 minus u squared under a square root. Now, this, again, immediate trig substitution. If I tried to do a u substitution, wouldn't help, but trig substitution works quite nicely. So I've got 4 minus u squared, and that matches the a sine theta thing. So I'm going to let u be 2 sine theta and proceed from there. So du is 2 cosine theta d theta. So I'm going to replace the stuff that's in here with what I just did the substitution for. So that would be 4 minus 4 sine squared theta times du, which is 2 cosine theta d theta. So 4 minus 4 sine squared theta is 4 cosine squared theta, and the square root of that would be 2 cosine theta. So I've got 2 cosine theta times 2 cosine theta d theta. So that is 4 cosine squared of theta. All right, so the antiderivative of 4 cosine squared, now you could use integration by parts here, or I'm just going to use the fact that I know what the antiderivative of cosine squared theta is. At least I think I do. The antiderivative of cosine squared would be 1/2 sine theta cosine theta plus theta over 2. And I'm going to put the plus c here. So now I need to get those thetas in terms of u's, and then those u's back in terms of x. So in order to do that, I'm going to come here, and this would tell me that theta is the inverse sine of u over 2. So I'm going to draw a triangle that represents theta. It's u over 2 and its inverse sine, so the opposite over hypotenuse is u over 2, which allows me to calculate this side, which would be 4 minus u squared. So now when I do that substitution, I'm going to get 4 times 1/2 sine, which is opposite over hypotenuse, cosine, which is adjacent over hypotenuse, and then theta, which is inverse sine of u over 2. And that would all be enclosed there. So I'm going to go ahead and distribute the 4 and substitute in for u at the same time. So here, I would end up with a 1/2 because the 4 cancels with these two 2's on the bottom. So 1/2 u, which is 3x squared, times the square root of 4 minus u squared, which would be 4 minus 9x to the 4th, plus 4 times this 1/2 would give me 2, and then the inverse sine of 3x squared over 2 plus c. And I obviously could write this as 3/2 and that would be just fine. But that is the antiderivative of this.